Hey guys, see, every single time. Hey guys, it's just, that's my thing, I guess. I just sent Kevin inside. He's the only one awake right now. The other two will probably wake up shortly, but hopefully my husband can handle it without coming outside to get me. And that's going to probably be not happening. We'll see. Now, what I have is the second page of that 4.1 handout in front of me, and I have everything I've written last time, but I also added in a recap of the write-in behavior. So the write-in behavior comes from, I put leading term, and then I was like, it's not actually from the leading term, it's just from the leading coefficient. The leading coefficient, if it's positive, then the right side goes up, right? So if it's positive, the right side goes up. I don't want to highlight that because that's in marker and that's a highlighter. Marker is going to smear it. But if it's a negative leading coefficient, it didn't smear it. If it's a negative leading coefficient, what happens? Negative, the right side goes down. Okay, on both cases, the right side goes down. Now, I'm going to go ahead and say, I'm going to highlight this in orange. There we go. If it's a positive leading coefficient, the right side goes up. So now what happens to the left side? Well, the left side, if you remember, the left side was dependent on whether it was an even or an odd. Even coefficient, both sides do the same thing. Both sides do the same thing. An odd, did I say coefficient? I meant exponent. An odd exponent, both sides do opposite, right? One goes up, one goes down. One goes up, one goes down. So if it's an even exponent, they do the same. Odd exponent, they do opposite. So the left in behavior depends on the exponent. Even means they do the same. Odd means they're opposite. Okay? There we go. So there's my little notes kind of crammed in there. So example 1, my notes start to be really, really hectic when I have to use one page for everything. Example 1 was match A through D with A through D. That's not very smart, but it maybe should be match 1, 2, 3, 4 with A, B, C, D, but whatever. So how do we do this? Well, we use the leading term. So I'm going to go ahead and I'm going to grab maybe this weird gold color, and I'm going to circle or box my leading term of every single one. Now, I automatically box those first two terms. That might not be your leading term. Yes, it's in the beginning, but your leading term by definition has the highest exponent. So what we really should do is check, is that the highest exponent? Yes, they're 4, 3, and then technically 0. So yes, that's the highest exponent. Yay, Jason's done mowing. Jason's my neighbor. So 3, 2, 1, 0 are my exponents there. Yes, this is the highest exponent. Here, 5, highest exponent. Yes. Here, 6, highest exponent. Yes. So these, those are my leading terms. Okay, so those are my leading terms. That's what I'm looking at. I am not looking at anything else. Nope, nada. I could care less what's following that, okay? So now, how do we figure out, there are like flies all over me right now. I must have, get away from me, a dog behind me. Dogs. No matter how many times you give them a bath, they still go out in the cow field, and they roll around, and they get flies all over. So now, hopefully the flies will go away. You won't see flies flying back and forth. So now we look at these leading coefficients. I'm going to focus on these leading coefficients. And what we did last time was we looked at A and we looked at B. And we said, okay, A is a positive leading coefficient while B is a negative leading coefficient. And remember, the leading coefficient, positive or negative, tells you if the right side is going to go up or down. So we look at this positive and we see, okay, positive 3, that means the right side's going to go up. So is it this one or is it this one? Is it A or D? I don't know. Yeah, you do. So I'm going to highlight in purple. I don't know if this is actually going to work. I'm going to highlight in purple this 4. Yeah, you can't really see that. I'm going to highlight that 4, and that 4 tells you what? It tells you that you have an even exponent, which means both ends are going to do the same thing. So if one side goes up, then the other side is going to go up. So which one has the other side going up? D. D has both sides going up. So little a matches with capital D. I'm going to go ahead and write the answers down at the bottom. Little a, or right here, little a, okay? So little a matches with capital D. So then we can look at, since I already have A highlighted, I want to go backwards. I want to ask this backwards. If I gave you A, which one of these, B, C, or D, which one of them would match A? How would you figure that out? Well, the first thing I do is say, well, the right side goes up. So my leading coefficient is going to be a positive number, right? So which one of these is a positive leading coefficient? Not -5, that's negative. Not -1, that's negative. +1, haha. Part C has a +1 leading coefficient, right? That leading coefficient right there is +1. So then I double check, what's your exponent? Your exponent is odd, right? Since that's an odd exponent, the other side should go down. The left side should go down. And it does. So C matches with capital A. Where's my marker? C, little c, matches with capital A. Okay? And this is an odd exponent, which means the left side is opposite. Right? The left side, if it's an odd exponent, then the left-hand behavior is going to be opposite of the right-hand behavior. Okay, so then we only have B and D to deal with. So B also, as we just said, has a negative leading coefficient, and that means your right-hand behavior is going to be going down. So we have it going down on both. So now when I'm looking at these, I'm again going to go through and say, okay, well, what about the exponent? I'm going to use that weird green color. Where's that at? There it is. Weird green color. When I look at this, I see one side's going down and the other side's going down. So they have the same end behavior. They have the same end behavior. Like both sides are the same. Okay, so what does that tell me? That tells me that it's an even exponent. It's an even exponent. So when I'm looking at C, I know I need an even exponent. So is that x cubed or x to the 6? Well, 6 is even, so that would be D. So C is paired with little d. That means that B has to match with, B. That's fun. Okay, so let's double check. This end behavior and this end behavior are opposite end behaviors. So that tells me that it's an odd exponent. And yes, that's a 3. 3 is odd. So capital B matches with little b. And that would be your answers. Okay, so let's go on to how do we graph this. So this, example 1, is a really, really, really good way of me testing your skills on a test. I just have to go through and double check that that is going to be an in-class test to be perfect. But an online test, I'm not so sure on that. So I need to, I want to ask you something like this. Ooh, I will. I know exactly how I'm going to ask that. Okay, you will have a question like this on your test, but, it might not be just that you have to know the concepts of this. So let's go on to this next part down here. Remember that word 0 or root? It does not go away. He's actually really, really, really important. So recall a 0 of a function is a solution of the equation f of x equals 0. And if they're real zeros are x-intercepts. So here we're going to do something really simple. Let me move this up a little bit. We're going to do something really simple here. And what we want to do is we want to find the zeros and then graph our equation. And I'm going to take this away. No, I'm going to leave it as graph. So here, I'm going to go ahead and use this blue. So to find the zeros, what do? Well, f of x equals 0, right? My y equals 0. So y equals 0. How do I solve this? 0 equals x plus 2 times x minus 4? Well, we already have it factored. Now we just set each factor equal to 0. So we would have x plus 2 equals 0, x minus 4 equals 0, and we would solve each of those. Really easy to solve each of those. You just minus 2 to both sides, minus 2, add 4, and you get back your solutions. X equals 2 and x equals 4. And that's it. Those are your two zeros, and those are your two x-intercepts. Now, if I go back and I look, I say, wait a minute, f of x is a parabola, right? That's a parabola. X squared minus 2x minus 8, parabola. So I'm going to go ahead and plot these points. I have, minus 2. Oh, let me grab my red. I'm going to grab this red. Minus 2, don't forget that negative. It's a negative 2, buddy. So let's go ahead and plot negative 2 over negative 2 over positive 4. So those are my x-intercepts, those are my zeros, and I know it's a positive x squared, so it's going to be a happy face, positive, it's a happy face. But instead of just sketching it, what I want to do is I actually want to take this a step further and find the y-intercept. How do you find the y-intercept? You set x equal to 0. Okay, so I'm going to switch colors. So I set x equal to 0. Do I have space down here? A little bit. I'm going to write down my f of x, f of 0, is, actually my f of x was x squared minus 2x minus 8. So what I'm going to do is I'm going to plug in 0 everywhere I see x squared and x. So here, this really should be x. So then I'm going to plug in 0. X squared is 0 minus 2 times 0 minus 8. So when I plug in 0, I get back negative 8. I plug in 0, I get back negative 8. So my y-intercept is negative 8. So I go down, spider, negative 8. And that is not my vertex, okay? My y-intercept is not my vertex. He is not equidistant between negative 2 and 4. Your vertex will be equidistant between them. So my parabola is going to be somewhere like, I don't know, something like that, okay? So I did not find my vertex. You could find your vertex, right? You could find your vertex of that parabola. I'm not going to. Okay, so that is how we sketch a function, okay? We're given a function, we factor it, we find our zeros, and then we plot them. Okay, next page. Lots more. So the next page, there goes the spider. So I'm doing all of this outside. There's not spiders crawling around my house or flies flying around my house or a lawnmower that's like inside my house. You will occasionally hear planes flying because I live like right next to Randolph, which I'm really surprised they're not flying right now. So let's go on to this next page. I'm probably going to do maybe just one example and then I'll start another video just for the time's sake. So this first one, example A. Find the zeros, x-intercepts, and graph this cubic function. So first, we need to factor it. Okay, so factoring it is actually going to come in another section on how to factor this. So we're not actually going to factor this right now. We're going to leave that for another section. But this is how you would factor it. Okay, this is the factors. These are the factors. 1 second. In or out? Stop hitting the door. You either come in or you come out. So these are the factors. So whenever you're given this function, you want to factor it completely. And once you have all the factors, you can continue on with how do you find the zeros, x-intercepts, and graphs. So here, when we have all the factors, we can then set each factor equal to 0. That's how we find the zeros, right? So we factor it. So we factor, and then second, we set each factor equal to 0, okay? So we have x plus 3 equals 0, x plus 1 equals 0, x minus 2 equals 0. And when we solve each of these, minus 3 to both sides, minus 1 to both sides, plus 2 to both sides. We have 1, 2, 3 zeros, okay? So notice our exponent is 3, and we have 3 zeros. These will always match. Whatever your exponent is, that is how many zeros you have, okay? Every single time. So now we have, I'm going to plot these. So the first thing is, what are the zeros? These are my zeros. What are the x-intercepts? They're all real. All 3 are real. So they are all x-intercepts. So now I'm going to plot them over -3, over -1, and then up 2. Over 2, sorry, not up 2. So those are my intercepts. Now, for the heck of it, I said, hey, let's try to find the y-intercept. Why not? To find the y-intercept, what I like to do is I like to go back to the multiplied out function. Why would I go back to the multiplied out function to find the y-intercept? Well, I know I'm plugging in x equals 0. But what happens when you plug in x equals 0? X cubed is 0, 2x squared is 0, 5x is 0, minus 6. You get back everything cancels out except for the constant factor of -6. So your y-intercept is -6. Now, plotting your y-intercept makes it a little bit harder to just go whee and graph it all nice and pretty. But how do we graph it? We have nothing to go on. How do we graph this? What we have to go on is our leading coefficient. We have to go back to the leading coefficient. The leading coefficient is +1. What does that tell us? That tells us the right side goes up. So our graph is going to go up over here. Okay? Then, what do I look at? I look at my exponent. What is my exponent? I'm running out of room. What is the exponent of our leading term? I'm sorry, I shouldn't use the word exponent. I should use degree. What is the degree of the function? Because that is the exponent of our leading term. Well, the degree is 3. And a degree of 3, that's an odd degree, which tells you that the left side is opposite. Left side does opposite. So if this side goes up, the other side goes down. So here's our graph. This is what we know for our graph. So now we need to connect the dots. How do you connect the dots? I'm going to actually grab a pencil. Hopefully you can see it. I'm going to grab a pencil and I'm going to wee. There we go. Great. That's my answer. Now there's a little bit more to it than that. Because all of our factors had an exponent of 1. Let me grab this weird ugly color. All of our factors had an exponent of 1. So that means that it crossed through, our graph crossed through at every x-intercept. Okay? So when you have the exponent of a factor is odd, then your graph crosses through your x-axis at that x-intercept. Okay? If the exponent of the factor is odd. So once you factor it, right here, once you factor it, if the exponent is odd, 1, 1, 1, then the graph will cross through the x-axis at that intercept. So here, see, it crosses through, it crosses through, it crosses through. When it's even, it will touch. And that's what we're going to do down here when we have a multiplicity, okay? So I think that's a good place to stop because example 2 is going to be a different topic, but very much related. Okay, and I need to quiet Kevin down. See y'all later. Not really. I'm not going to see y'all for the rest of the semester. We can't gather in groups of like 10. I'm pretty sure they're going to restrict that down even further soon. So if I see you, politely stay away, social distancing, social distance from everybody. I didn't even know I was sick, and then bam. Now my mom, she didn't know she was sick, and bam. Yeah, okay. Anyways, stay safe, wash your hands.